Hello everyone and welcome to a new chapter. We are starting off in chapter 8. We're starting off with lesson 8.2.1 and we're diving into exponents. And can you figure out the pattern inside of exponents? We're going to develop the rules that help govern this side of mathematics. Now, we've been dealing with lines, right? But now we're going to start developing an understanding of exponents and how that kind of makes things a little bit different. And today it's very much a code. It's a math code, okay? Exponents are written in math code. For example, this problem right here, 2 to the third power, that's how you would read this. This 2, it's larger, we call that the base, okay? In exponential form, that 2 is the base, okay? And this 3 is the exponent. And we would read this 2 to the third power, or 2 cubed in this case, because it is a 3. And so today I want you to notice that we use this in real life in the Richter scale. That's how we measure earthquakes. We also use exponents in the pH scale. Okay, that's how we measure how its alkalinity and acidity. Okay, how far away from pure water it is. Pure water has a pH of 7, and so it goes on that scale. But it's dealing with exponents. And notice this scale is a curve. It's not a line. And notice the difference between 3 and 4, not that big. The difference between 7 and 8, really big. Okay? This is the exponential idea, dealing with these curves. Now, this code that we have codes all over the place, whether it's texting or basketball or cars. The question is, can you figure out the math code? Notice this right here, m to the third power, that's cubic meters. That means that it's volume. Over here, square meters looks like this, because we don't want to write meters squared. We want the shortcut, Mr. McCoy. It's just an abbreviation. And so we need to recognize that in all areas of life, people have created shortcuts. So why can't math use math shortcuts? And that's what we're doing today. So we are going to focus on identifying patterns in exponents, defining a base, defining exponents, rewriting numbers using exponents. We are focusing on those 4 areas. Now, problem 8-36. Is 3 to the 5th power the same as 3 times 5? Well, tell me, guys. You know 3 times 5 is 15. Is this the same thing? Your knowledge of 5th grade, when you were first introduced to this, should tell you no. Because we have to break the code. 3 means, oh, my blanks got moved around. No. Because you have to write down the base 5 times. So notice I'm going to write this out. No, because we have to break the code. 3 means you write the base 5 times. 3 times 3 times 3 times 3 times 3. Then multiply. I go this way. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 81 times 3 is 243. Now I can do this math in my head because I have done this so many times. But I want you to recognize this and this are not the same. That's why we write it differently. So I want you to notice 8-37 has some additional information that I want you to write down. Parts of a power. Now you have a bunch of room over here next to your chart. I spread it out so that it can be big enough. I want you to pause the video and record these 3 sentences before I continue. Pause the video now. Okay, you have all this stuff written down. The parts of a power, the exponent tells us how many, and notice mathematicians are lazy. Notice if you just see a number, it means that there's an exponent of 1. So when I go through this, most students don't have any problem with this half of the table. So what I want you to do, I want you to look at the example, and I want you to complete the top half of that table, then resume. Pause video now. Okay, you have these recorded, and you have done the top half of the table. Now, when I look at the bottom half of the table, I must switch colors so that you can see. In this first half, here's what we've done so far. X to the third power tells me that there are 3 x's. Y to the second power tells me that there are 2 y's. I'm going to switch colors to represent this portion. Most of the time, people are tempted to say that that exponent of 2 belongs to both of them, and it doesn't. Please remember the invisible 1. That's why we wrote this down. That x, its exponent, is invisible, the invisible 1. And so I'm just going to write 1x, y, y, because there are 2 y's. Now, when I record my final answer, remember, exponents tell us how many times the base is there. 1, 2, 3, 4. X to the 4th power. 1, 2, 3, 4. Y to the 4th power. Now, when I go through these, I am simply counting how many of the base there are. Go ahead and finish this table. Pause the video now. All right. Now, before I move on, I want to notice the pattern that we were developing. Okay? We said 5 squared, 5 and 5. 5 to the 5th power. 1, 2, 3, 4, 5. How many times did I write the number 5? Oh, 7 times. 1, 2, 3, 4, 5, 6, 7. Is there a better way? Is there a better way to, I don't know, find a shortcut that allows us to figure out how many there are? Because an exponent tells us how many. So how many are there? Well, I noticed that the number 5 stayed the number 5. I didn't combine them. Notice I did not say 5 times 5 is 25. Notice the base stayed the same. Notice all I did was copied down the base. And what did I do with the exponent? The exponent 2 and the exponent 5 became the exponent 7. Oh, I noticed, Mr. McCoy, that you copied the base and you added the exponents. That is the pattern you needed to see in this table. So underneath, you have several lines for A, B, and C. Problem letter A. I noticed that we always copy the base and add the exponents. This is the pattern that you have to see today. I did not combine the base. I didn't take an X and I didn't take a Y and make this hybrid letter. Nope, it just stayed X. How many X's are there? How many Y's are there? How many 5s are there? How many 2s are there? How many 3s are there? I did not combine them. So problem letter B. Simplify this. Well, do you want to write that number 20 that many times? That would be insane. So what do? Well, I notice that we always copy the base and add the exponents. So what do? We always copy the base and add the exponents. Do it. Pause the video and do it. Now I want you to notice there's a sentence here, and the question is, do we need to use expanded form? Right? Did we need to expand this out? And I want you to notice we're going to respond with no. No, we don't need to use expanded form because I know I can copy the base and add the exponents. Okay? I want you to see this today. Problem letter C. Can you simplify this expression to get this expression? Well, tell me. This word always means always. When you are multiplying numbers with exponents, you are always going to copy the base. Did the base get copied? No. Because the base has to be the same. Here, let me get this blue out of the way. No. Because the base has to be the same to simplify. Notice, if you're going to put this 3 and this 4 together to get 7, you have to have the same base. If you don't have the same base, you don't put them together. Next problem. Go ahead and put your pencils down right now. What you should have learned by now is this rule, okay? We have to first of all say, what's the base? Well, if the base is x or the base is 2, that's what we need. What's the rule? Copy the base, add the exponents. That's why it looks like this. Copy the base, add the exponents. How many times is the base multiplied together? So you could go to expanded form. There are 2's. There are my 2's. Let me go ahead and get my x's. And then I can count. Okay, how many 2's are there? 1, 2, 3, 4. How many x's are there? 1, 2, 3. Now, this is expanded form to prove the rule, or do you just want to say, I notice 3 plus the invisible 1 gives me the 4. This is the rule. Notice the base got copied, 2, and I added the exponent. 3 plus 1 is 4. The x is the exact same thing. I notice there's a 2, an invisible 1, and it turned into a 3. 2 plus 1 is 3. This is what you have to learn. Copy the base, add the exponent. Okay? So here we go. 838. When you multiply, the order of factors does not matter. The order does not matter when you are multiplying. Okay? That means if you multiply 3 times 2 times 3, and if you multiply 2 times 3 times 3, the commutative property of multiplication allows it to happen. So problem letter A, let's verify. You're going to write, what is 2 times 10? 20. What is 10 times 2? Also 20. Notice the commutative property allows you to switch. Is that true with division? Well, 2 divided by 10 is 0.2. 10 divided by 2 is 5. Notice I got a different answer. That's because the commutative property does not work with division. It works with addition, does not work with subtraction. Okay? The commutative property. So, let's use this idea and be able to rearrange it. Okay? I want you to do B and C on your own. Whether you need to use expanded form or not is up to you. Pause the video now. All right, 39. All right, 39. I ran out of time, so you got to do 39 and 40 on your own. Pause the video so that you can see 39 and 40 on your own. Thanks for coming today. Sorry I ran out of time. We'll see you next time.